Good evening, ladies and gentlemen. Two important issues at the international level relating to Japan have recently stolen the attention of all of us. And we in NIASSC felt that we have to know more than what we read and understand from the newspaper reporting. So the NIAS Associates program felt to see that we have to invite two distinguished personalities in the field who could tell us more than what we can reasonably understand from newspaper reporting. And today we have in our midst Dr. Kusala Rajendran and Dr. M.R. Srinivasan. We cannot have better than these two personalities to enlighten us. First, Dr. Kusala Rajendran. Now she is an associate professor, Center for Earth Sciences in the Indian Institute of Science. Briefly, I would like to introduce her. She obtained her Masters of Technology, applied geophysics in 1979 from IIT Roorkee, and Doctor of Philosophy, Seismology in 1992 from the University of South Carolina, United States of America. She has extensively researched in the fields of tectonics, crustal processes, role of water in faulting process, paleoseismology, earthquake and its recurrence, and active tectonics, tsunami-related problems. She is the recipient of Krishna Gold Medal from the Indian Geophysical Union for her contribution to the field of geophysics in 1993, and Tahor Award in 1992 from the Department of Geological Sciences, University of South Carolina. She is a master. She is a member of the editorial board of the Current Sciences and also Journal of the Indian Geophysical Union. She is the principal investigator in the ongoing research project titled Constraining Tsunami Cyclicity and Research, Education, and Manpower Development in the discipline of earth processes. She has published several papers, as many as 50 papers in national and international journals. I request Dr. Kusala Rajendran to take the floor.
Good evening to all of you. Thank you, Dr. Settar, for that introduction, Professor Ramurthy, all distinguished guests. As you see, I'm just going to spend the next 40 to 45 minutes trying to share with you what information I have assimilated over the last days since the Japan earthquake occurred. What you see on the screen is now familiar sight of the turmoil that was created after the Japan earthquake, the Pacific Ocean gushing to the highways of the streets of Sendai. Pacific Ocean has similarly gushed very ferociously to the streets of the coastal plains of Japan in the past, and people in Japan are quite familiar with the arrival of tsunamis. What was probably different with this event was that it crippled the infrastructure of a modern city, and it caused unprecedented damage to a nuclear facility, which looks like the major concern today, because Japan has had similar disasters in the past, and they relive, they live, they reconstruct and then come back. So this is the major concern, seems to be the nuclear disaster. I would just begin my talk by quoting with a quote from a social scientist and historian by name Will Durant, who said that civilizations exist only by geological consent. It looks like the consent was withdrawn on March 11 on the Sendai coast. I wish to also emphasize that all these processes, the plate motions, earthquakes, tsunamis, volcanoes, all these are part of the natural processes that have been shaping the earth. And these are all parts of the natural processes of this dynamic earth. Let us explore the reasons behind this turmoil and try to understand and learn how we can deal with this. You have to remember that all these become disasters, all these become tragedies because human beings are there. So we have to understand how to give space for the nature's forces to operate. So let us try to understand what drives these processes that eventually leads to such turmoils. I just structured this talk in 5 different parts. One is just the tsunami distribution and basics of plate tectonics, without which we cannot understand why all this happens and where it happens. I would just briefly discuss the tectonics and regional seismicity of the 2011 earthquake. Then I'll talk briefly about the effects of the earthquake and what happened, the crustal deformation, etc., and come to the vital issues of seismic hazard evaluation, what are the kind of techniques available today and what was available for Japan, and then probably the most crucial issue of that is being debated on whether there is a threat for tsunamis and what's the context in the Indian situation. Just a brief review of where are the tsunamis. About 58% of the tsunamis occur on the Pacific Ocean, 4% in the Indian Ocean. This is including the 2004 tsunami. There is 12% in Atlantic and 25% in the Mediterranean. What are the causes? 72% of them come from the tectonic reasons, about 10% come from landslide, and 5% from volcanic, and then other issues like meteorite impact, etc. And these are some of the historically known great tsunamis, that Nankaido, then you have this Krakatoa, this is an explosion, and then Sumatra and the recent Japan, of which we don't even have a proper estimate of the death toll. Without understanding the plate tectonics, we cannot understand earthquakes and tsunami generation. As we all learn in basic the earth science courses and classes, the earth dynamics of the earth is controlled by the several plates that are moving, and newer plates are created at these white patches, which are called the mid-oceanic ridges. And as plates keep moving, like Indian plate is moving towards northeast, they get subducted beneath another plate. They collide and they form large mountain chains, or they subduct beneath another plate when oceanic plate is subducting beneath a continental plate. Such are the sites where you have great earthquakes, and some of them can be tsunamigenic because the displacement from the earthquake occurs on the ocean floor. So these are all the subduction, and you can imagine that places like Chile, all these places are the places where there are subduction zones, and they are in fact the seat of great earthquakes. So if you just imagine, just memorize that picture from below, from my previous slide, these are the plate boundaries where smaller earthquakes occur. These are called diffuse plate boundaries, where newer material is being generated. These are intra-plate regions where you have fewer earthquakes, like we are in Bangalore. All these places are generally, these are only magnitude 6 earthquakes and above. So you won't find many earthquakes in these regions, which are called stable, and they don't generate so many earthquakes. But you come to this area, these are the Pacific Rim of Fire, where you have all these great earthquakes. And these are related to the subduction zones, and also the volcanoes. So this is basically the area where you have most of that. And if you recall, that is that 72% of the earthquake. Some of the largest thrust earthquakes that have occurred, this is your Sumatra 2004, this is the 2011 great earthquakes. All these places are the great earthquakes. The exception is this Lisbon earthquake, which was not close to an active boundary like this, but it also generated a great tsunami-genic earthquake which killed several thousands of people. What drives the plates? It's basically, Earth is the only planet that we know today that has a very active plate dynamic process, because it has got a mantle convection process because of the thermal and density stratification of the Earth. So you have the molten outer core, which drives plumes, which are creating these convection currents, and in some places they get escaped through whatever you call as the ridges. And the lithosphere, which is about 100-kilometer thick plate, that is sliding over the asthenosphere. There is a slightly partially molten material here, which is what moves because material getting pushed from the ridge, and they get subducted here, and that's what you call a trench. So this is the radioactive heat and the changes in the temperature that drives the whole thing. And because this kind of structure does not exist for other planets, such plate tectonic forces and earthquakes are are not really known in other planets. This is the structure of a mid-oceanic ridge. You have hot material coming from here, and they just keep on moving. And as it comes close to another continental region, it will dive down because it is very dense. And as it dives down, a lot of lighter material mixed with water comes back, and they become the volcanoes. So I won't be surprised if the volcanoes in the Pacific also get activated after the Japan earthquake, because a lot of activity starts here, because a large plate, a large volume of material has actually gone below, and they are now going to get mixed up with the water and it will come back, and the whole material here has changed, and it might trigger the volcanoes. So this is what the basic dynamics, and it creates several fault systems. And what we really have is when you have a thrust earthquake here, that is, thrusting is when there is a plate moving over the other. That is where you will have this great tsunami-genic earthquakes. I'll skip this except to remind you that when a continental plate collides with another continental plate, like Indian plate collided with the Eurasian plate, you have the continental arc, that's the Himalayan mountain chains, where both will just rise over the other. But in this particular case, it's an oceanic plate that is subducting beneath this plate. So here you have a subduction zone, and here is also a subduction, but it is conventionally known as collision because you have a mountain chain rising here. And here is your subduction zone, and this plate is moving at 5 centimeters per year, whereas this plate is moving about 90 centimeters per year here. And this is the place where this plate, Philippine plate, was moving against the Eurasian plate, where periodically or at intervals of hundreds of years or a few tens of years, earthquake keep happening. So with this, you can see that all the great earthquakes have occurred along this patch, except this one out here. This is the Himalayan, this is the Sumatra earthquake. This is also a great earthquake, the Assam earthquake of 1950. So these are the 5 great earthquakes of magnitude more than 9, all 4 of which occurred in this Pacific, except the Sumatra earthquake. So this is the basic, these are the great earthquakes. This is again the Pacific Ring of Fire, where you have the volcanoes and the earthquakes. Now, why do these earthquakes, what kind of earthquakes actually create the tsunami? See, what happens is, here is the subducting plate, and as the plate subducts, this is a dense oceanic plate, which is trying to grind here and come down. And there is always a push from here and push here. So this part develops a lot of resistance, a lot of friction. And it is almost like it's called locked. And when that lock opens, that is when you have the great, what you call the great mega thrust earthquake, because this is thrusting over the other. And it has been building up stress for a long time, and it finally releases that stress, and it will just create a displacement on the ocean floor, and that will actually push up the water. Normally, these are about 25 to 30 kilometers deep. So what happens is, here is the rupture on the ocean floor. This is the this rupture, this slip in the source. The source slip of this earthquake, 2011 earthquake, was 24 meters, and that slip gets translated to the ocean floor. This could be about 10 meters on the ocean floor itself. So you are imagining a 10 to 12 meter slip of the ocean floor, which dislocates the whole land, and the tsunami is triggered like this, and they start moving towards the land. As you know, there is a deeper water column here, like you have shock waves here. This is what you call a fault. A part moves up and part moves down, there's a displacement and the shock waves are generated and water start moving, and they start moving at about 500 miles per hour. And as it reaches the land, the depth will reduce and it will amplify and it becomes a tsunami, and and also depends what is the geography of this region. If it is a very undulated, it's a very flat terrain without many undulations, the tsunami reach is very far. That's exactly what happened in Sendai Plains. It was a very flat topography. The tsunami can travel as far as 5-6 kilometers. If you recall the 2004 earthquake, even in the east coast of India, it traveled as far as 1.5 kilometers inland at places called Kaveripatnam. This is a cartoon which I have adapted from a Japanese book, which shows the Japanese, they really live on the subduction zone. They are aware of this, and they plan their buildings, and from their childhood onwards, they are taught how to deal with earthquakes and volcanoes. So here in this cartoon, what you see is the normal situation where subduction is continuing to take place. This plate is subducting below, and people live right on top of here. And this is the Pacific Ocean, the strip of the Pacific Ocean. And then the earthquake comes. The earthquakes generate a shaking. This would, it would not create the tsunami immediately. It just, the shaking, and some buildings may survive, some may not survive. And the next phase, maybe after about half an hour, or depending upon how far you are, the tsunami comes in. So this cartoon is just illustrative of the different stages of tsunami. So how fast it travels and how fast it reaches you depends on how close you are to the source of the earthquake. So we're coming to the Sendai earthquake. So this is the source of the Sendai, the earthquake of Honshu Coast earthquake, which is about 130 kilometers from the Sendai coast. Here the Pacific plate is subducting beneath the Japan Kuril trenches. And this is there have been fewer earthquakes here in the recent past. And this is the location of this earthquake, and Tokyo is just south of here. Now I'll just briefly go over the seismicity and tectonics of this region. Here I have what's a picture of the Aleutian Trench, Kuril Trench, and the Japan Trench. This, I have to remind you that this area has been the site of 3 magnitude more than 9 earthquake, one in 1964 in Alaska, 1952 Kamchatka, and this one. So this is the seismically most active region. What's overprinted, this pink shade, this is a picture created by one of my students taking data from various sources, and this is what she has overprinted is the rim of the Pacific Ring of Fire. So this is the area, and this is the area where we are going to concentrate mostly on this area. This is also coming as a short paper in the next issue of Current Science, and I think this is coming as the cover photograph. So here is the tectonics. I have already explained this. This is the Philippine Sea plate subducting beneath the Eurasian plate. At about, at this point, it's about 51, and this is about a maximum of 99 centimeters, 90 millimeters at this place. Now, this is a picture again that we have compiled from the existing sources. This shows this area, all the magnitude that earthquakes are plotted are actually more than 8.5, more than 8. And this is the earthquake. Now, you can see that this is not an area where earthquakes are a surprise. Earthquakes have been occurring here, and they have studied this so extensively that there is a theory that you can get an earthquake of magnitude 7.4 or 7.5 every 30 to 40 years. And here is the statistics of the recent statistics. There is 1835, 1897, 1936, and 1978. So the next one was expected any time. My own personal belief is that there was an earthquake on March 9th. It was of magnitude 7.2, and probably they must have thought this is the earthquake that they were waiting for. But after 2 days, the big one occurred. What we, based on the observations elsewhere in other subduction zones, what is probably happening in all these subduction zones is that we have shorter cycles, which are of 30 years or 40 years, depending upon where you are, and you have super cycles, which sort of ruptures through even other earthquakes and whatever has happened. They occur over longer intervals. And here the shorter cycle seems to be 30 to 40 years, and the longer cycles, so the super cycles, seem to be about 1,000 years. Now this is not surprising because the same kind of observations are made also in the Indonesian or Sumatra subduction zone. Again, we believe that the super cycle is of the order of 1,000 years, but you do have earthquakes which occur otherwise. So this is the key issue is that we do have earthquakes, and except that they probably miscalculated the super cycle and probably the size of the earthquake. Now coming to this earthquake, it ruptured this particular area. This is the main shock. I won't dwell too much on this. If we'll discuss it if it is required. This is the area that actually got ruptured. And these are the seismograms that show you that this is the main earthquake, and so many earthquakes actually after that has occurred. This is basically how a typical seismogram of this one is clipped because it is too much energy than what the magnification would allow. I want to just talk about the energy release of an earthquake. When people talk about energy release, you must understand that when you have a change of magnitude 1, the ground motion changes by 10 times, energy release by 32 times. So between a point 1, you have a difference of 1.4 times energy release. And what does this mean? The energy, of course, is calculated from the moment, which uses the displacement, shear modulus, such factors, and then you can calculate the moment of an earthquake. There are various formulas that calculates the moment. But in terms of common man's terminology of understanding all this, this energy release at the Chennai earthquake was equivalent to 9.32 tetratons of TNT, approximately equal to 600 million times that of the Hiroshima bomb, or about 80 years of global energy usage, estimated to be about this kind of amount for 2008. So that's the kind of energy release that took place during this earthquake. Aftershocks, I won't talk too much about it, but here you have all these aftershocks. Once a great earthquake occurs, it will upset the whole area and even the neighborhoods that you will have continuously aftershocks occurring in this area. Now, this earthquake, of course, caused several effects. This picture is just the storm motion. Just after 1 second, about 50 seconds, it is spreading. 90 seconds and 180 seconds, you have the ground motion picking up. What does this mean? Again, these are some of the stations which record the maximum ground motion. You can see at some places, I find it so difficult to believe that it is 2.9 G at some places. And this may be site-specific because of certain filling factors or the lithology, but you have accelerations going more than 1.6, at many places. So this is the acceleration that. This is the way that the landscape looked like just before the earthquake, very quiet area, and this is the post-March 11. And I really don't like to show these disturbing signs of the tsunami, but this really shows you the power of the tsunami that lifted this car up and kept it on this 3-storied building. Usually, the Pacific warning system is operational. Pacific warning system operated also by the NOAA. They generally have a tsunami travel time calculation. So immediately after an earthquake, the kind of parameters that I just showed you, like they use the rupture, the style of faulting, the depth of the earthquake, and calculate. They can issue a tsunami warning, and it will tell you the travel times of what the tsunami is going to be at what time. So this is the typical tsunami warning issued by NOAA within a few minutes of this earthquake. Like in Chile, it was expected to arrive 21 hours later. The Sendai was located just 130 kilometers away, and the arrival time, the available time was just 30 minutes. I believe that several mobile phone warnings were issued. I read about, I was most touched by a story of a 82-year-old grandma who just picked up her cycle and nothing else, and just rode her cycle, and she was later in a rescue, in a rehabilitation center. That reminded me of the fact that all your belongings, she left everything. Many people may have stayed back trying to pick up their belongings. She just took her bicycle and left everything, and she just made it. This is to again show you the power of this kind of production, the prediction. So this is the actual this is the tsunami travel time predicted by the NOAA using a source model here, and this is what's actually observed by all these tide gauges and reconstructed. It is pretty much very much comparable, except in the very, very near source where the turbulent flow is beyond the predictions of simple shallow. The simple equations don't, the shallow water equations that are used for such propagations won't explain the complexities of the near source dynamics. So I think that's why there is a small difference in the arrival time predicted by the tsunami and the model and also what is really observed. This is the tide gauge. These people also have a lot of gauges on the ocean floor. So this is the shaking time, that the tide gets disturbed, there's a trough, and then the gauge gets disabled at this point. So this is the wave height, which is recorded on some of the ocean bottom tide gauges. These are the gauges which are all around this place. So this Fukushima plant is further north. This was 7.2 meters. This is from a Japanese agency, so I don't have the locations of this. This is a kind of, you can see they are not linear. They depend on the shape of the coast out here, the height. I'll just explain a few things. That here, this is the slip plane that happened again, and this is the rupture that occurred. And the slip at source, like I said, was 24 meters. The Sendai, this is the slip that is a trench. Now, again, the tsunami model, the tsunami will be modeled using this. So this is a rupture point starting here. This part goes up, this part goes down, and this is the way the tsunami is modeled. And people generate, this is the fundamental model that is generated to develop the tsunami model, and which later works into the tsunami propagation model. So this is based on seismograms. That's why it's very important to understand from the seismogram what exactly happened at this source, which is about 24 kilometers below. So these are all instantaneously done, near real-time estimations of the waveform and model, and they come up with this. So anytime there's an earthquake, within a few minutes they will compute this. And there are typical algorithms that will work out this, which will lead into the propagation model. The land shape, the changes of the land are really amazing. Things happened here. The land shifted to the southeast in this direction, about 10 feet. They still follow these are all from the Geographical Survey Institute of Japan. Also, there is an upward. It was almost like a 1 meter down throw here. The land dropped. So here, all GPS stations are all here. So they immediately compute all these. So these are the dynamic, the great land level changes that occurred just after the earthquake. Now we'll go into the seismic hazard evaluation. See, everybody knows that in a place like Japan, the history goes back to a few thousands of years, and there are records of the archival information that tells you when earthquakes have occurred here. If you go to places like United States, the history is very short, maybe 300 years, and the information available to them is very little. The Japanese also use tools like tsunami geology to understand what could have happened in the past, so that they can develop an idea of the kind of the pattern of recurrence. Here is a very impressive study that came out in 2001. I was not really aware of this paper until Minora was actually interviewed by Science or Nature, one of them, and he made a statement, and that took me to this paper. What he did was, they looked at the land deposits of previous tsunamis and came up with an age estimate of 8962, which was also historically documented. What was most interesting was, these deposits were as far as 4 kilometers inland. So from that, they concluded that and they already have earthquakes of magnitude 7.5 or 7.8, and they don't bring in that kind of tsunamis, deposits 4 kilometers inland. So they concluded that this has to be a great earthquake and not the usual earthquake. Impressively, they used the dynamic flow characteristics out here and modeled that this could be the tsunami source. Just remember this benchmark, this locations out here. So this is their tsunami source, and the predicted height is 8 meters. And here is actually the tsunami source here. You can look at this patch. So this is just a little south of that model. So it was actually, and they also stated that we can have an earthquake. They have a 1,000-year recurrence, and they suggested that the Jogan tsunami, which they named, is much larger than what was generated by a normal sequence of earthquakes. And when the actual tsunami occurred, this is pretty much the same area with a slight difference in the overlap. So this was actually an 869 earthquake, and it was 8.3 according to these estimates, and they went 4 kilometers inland. Such are the data that go into the seismic hazard evaluation where you don't have instrumental data. See, if you want to work in the Indian coast, we don't have instrumental data, or we don't have historical data going very far back. So we have to rely on the geological evidence of the past earthquakes and tsunamis, which is also one of my research areas. There have been earthquakes in the past. Here is a 2011 earthquake, and here is the 1896 earthquake, which is one of the largest earthquakes which generated a wave height of 25 meters. You can see the destruction from that old Japan. This is the tsunami created by that earthquake. Here also there is another. I show this very deliberately because every time we have an earthquake, we go back and look at issues, and we realize that there are so many things which we just don't know. Here is a case where the model predicted that this 8.6 could not generate such a huge earthquake. So the prediction was that because it occurs very close to the sedimentary wedge, what you call this is a sediment pile, the sediment itself moves up. Sediment itself moves up and amplifies the magnitude. So these are kind of things which people do, and the more you have evidence, the more you can refine your model. Based on all this, people make their futuristic projections of seismic hazard. So interestingly, this is the government's official seismic hazard map. They said that this is the region which was of highest hazard. The Fukushima prefecture was considered to be in an area where the risk was at the lowest. So here they expected a magnitude 7.5 in the next 30 years, and possibly even a magnitude 8, but not 9. And when 8 becomes 9, it is a different story. Unlike most other countries, Japan also updates its hazard maps. And here again, this is the Miyagi-Ken-Oki region where they said 99% probability for 7.5, which did occur on March 9th. But the maximum they said is 8. So here was the problem of underestimation of the size of the earthquake. So this is the official map, which they keep updating based on more and more information coming in. People talk about seawall. This is the most amazing thing I've seen, that there was a seawall. The seawall was, as the Japanese called it, the Great Wall of China. It is Japan's Great Wall of China, because it was a long wall, which is about 1.5 miles long, and also it is so broad that people could drive their bicycles on that, and they could jog on that. On the day this happened, people were taking a stroll on this the seawall, and here is the power of the tsunami that they brought a whole ship and sort of broke this wall. It destroyed the inner wall, and it tore through the outer wall, and it was totally destroyed. It's a picture which I picked up from the March 31st New York Times. Now we come to the threat from tsunamis. Can I have a little water? The threat from tsunamis in the Indian context. Until the 2004 Indonesian earthquake occurred, I don't think that any of us really worried about tsunamis. We never really thought about tsunami. I don't think there was anybody working on tsunamis or talking about tsunami geology. So this is a picture obviously put up after 2004 earthquake. These are some of the sources. This is the 2004. This is what we call is a rupture zone. This was 1,300 kilometers long rupture, generated tsunami that propagated perpendicular to the rupture zone, which affected all these areas. These are smaller ruptures which created smaller tsunamis which affected only the Indian Ocean, the Indonesian area, Sumatra. Here is another Krakatoa explosion, also creates tsunami. 1883 explosion created a tsunami which reached the eastern coast of India. These sources at least were well known. 1945 tsunami source at Makran, although it occurred in 1945, it was not really talked about much until this earthquake occurred. So we started taking stock of what are the other sources. So we chance on this, okay, there is another one here. So these are the sources, the 1945, and there is another source here, 1762, there was an earthquake in the Arakan coast, 2004, these are smaller ones, and then the Krakatoa, which creates only a small tsunami here. If you look at the 2004 earthquake, we have had, like I said, we also have smaller cycles and super cycles. We have had earthquakes of 7.9 in 1881, 7.7 in 1941, and this is the 18, I think this is 1879 something here, and all these smaller patches. What happened in 2004? It originated here and ripped through the entire length of the subduction zone, unlocked all the locked patches, and propagated very large distances. Such tsunamis, what we call the predecessor of such tsunamis, are what creates a supercycles. And here we believe it is about 1,000 years. So we have smaller ruptures like this and a super rupture in 2004. This earthquake, so we also dig up what is available and then try to find out how we can actually find out the past earthquake. So here in our study we used the proxies of the 2004 earthquake, like land goes down. I explained how the GPS shows land has gone down. Here is a very dramatic picture of the mangrove forest that subsided by 1 meter in Port Blair just after the earthquake. Eventually, this will be inundated by salt water, which mangroves don't survive and they just die. And they become just maybe just the tree stumps remain, which we go and pick up later. Here is the uplifted part. This is a Sentinel Island where only the North Sentinelese, the tribal people live here. We can't actually go here. You can see the uplifted coral. This was uplifted by 1 meter. So what we do is we use such geological proxies to recalibrate and calculate the age of the older event. So here is an example where we see the older subsidence of land, and which leaves an array of the tree trunks which are dated at about 1,000 years. In addition to our dates from east coast of India, which I am not showing here, we date this earthquake, the previous one, as about 1,000 years old. So we have the Tohoku earthquake was a repeat of the AD 869 earthquake, and Japan subduction zone may have 2 types of cycles. The shorter cycles could be of 7.5 earthquake. The larger one seems to overlap the ruptures from smaller ones. They may occur over longer intervals, and a size variability that is observed in other subduction zones such as Chile, North America, Kuril, and also possibly in the Sumatra Andaman. So for the Japan subduction zone, the supercycle could be of 1,000 years. There are also possibilities that you have secondary sources, secondary effects of earthquakes. One of the areas that we are working on is the possibility that a smaller earthquake, like a 7.5-ish earthquake, can it trigger a landslide, and can it create, still create a tsunami? So these are some of the other secondary effects of the rupture. So it need not be a 9, it can also be a 7.5 or 8, but where you have large sedimentary thickness, it can still trigger tsunamis. Volcanoes, like I said, the Krakatoa actually has triggered the tsunamis. And here you see, this is the Krakatoa explosion triggered by the tsunami reached Nagapattinam. It was like a few centimeters, 0.5, I think, yeah, it's just about half a centimeter, that, half a meter, I think, yeah, it's about less than half a meter that reached in the Nagapattinam. At that time, there were some gauges for the development of port city. So this is a model that somebody has generated using the arrival times and back calculate. The wave height was half a meter. Now over to the Makran subduction. This is, yeah, because it is very far. The tsunami originated from Indonesia. So it is Nagapattinam. This is Nagapattinam. That is very, very small. Now over to the Makran subduction zone. Makran subduction zone is where the Arabian plate is subducting beneath the Eurasian plate. This is the Makran subduction zone. Not very well, not defined by too much of seismicity, But there was an earthquake of magnitude 8 in 1945. It is the largest known recent earthquake that generated tsunamis. It is reported to have attained a height of 8 to 10 meters in the Gulf of Kutch. Gulf of Kutch because the Gulf area, into this bay, the wave enters and it resonates in that small Gulf, and it sort of amplifies in it, picks up amplitude. This is a model based by one of the famous tsunami modelers by name Murthy. So this is the kind of data that we are talking about. It was still reported. This is a Times of India report of November 28, 1945, which talked about the tidal wave hitting the Bombay shore. Entire family washed away, and 3 women drowned in the Versoa Creek, which is today's Mallard Creek. And this is the tsunami entering in this creek and then probably washing down the houses in the nearby area. So I don't think that anybody took all this seriously until the 2004 earthquake occurred. We dug up this from the Times of India archives while looking for historic documentations on past tsunamis. Again, the issue of whether it was triggered by a landslide is another issue, because there is a delay between the arrival time and the models. It's another problem that we are actually working on. There was a misfit between the reported time, because people used to live here and they say that this is the time earthquake occurred and the tsunami came much later. So there is a possibility that it was triggered by a landslide, and looking at the offshore, the morphology, we do find that there is a sliding. I don't know whether you can see it. You can actually see a slumping here. We are working on this. This was the delay between the observed and the calculated timings. So we are working on the model for the landslide as well. Now, which are the other sources of this area? This is a 1945. This is 1765 and 1851. So these are the ruptures, but we really don't have a good history of when these have, what is the size, what was the other earthquakes. It is a difficult area to work, and there is something reported in 1483. It's again a question of where was it? That is something that we need to find out. Now coming to the question of the hottest issue of nuclear power plants. This is a picture that I took from the recent issue, March 25th issue of Science, which carries a series of articles on the nuclear fallout in Japan. And they put this map to show the locations of Indian nuclear plants, 20 of them operational, 5 of them operational and 20 in plan. And this is the Pakistan, there is 1 operational or 2 operational, 1 in plan. It's the other way. Okay, 20 are operational and 5 are in construction. This top one is the operational one. What is important to realize is that there are, now to come back to recap about the sources, there are 2 sources. One is its lead time before the tsunami comes. If you are far away from the source, the tsunami travel time is estimated to be about 4 hours. Now our plans, this is purely my own personal judgment. I believe that our plants are located sufficiently far away from the subduction zones, and we do have a tsunami warning system operational. This can actually give you a lead time of 5 hours, 4 to 5 hours, which can essentially help you shut down the operations. That's what I believe. And there is no immediate threat. There is no real threat as you see in the Japan, because I underline that point. We are sitting 4 or 5 hours travel time away from the active source of the tsunami generation. However, if you come to this area, there is a power plant here. I don't know the exact location of this plant. This is again from here. What is the height of this location, I don't know. But this is dangerously close to a subduction zone about which we really don't know much. So if at all, yeah, that is in Pakistan. That's Karachi's one plant. So this is the Makran subduction zone, and this is the Pakistan plant. So some Google images we looked at did not show much elevation in the change in the elevation of the topography. So it looks like a plain land where tsunami can actually reach. What is dangerous is that unlike Japan, not much of work is going on here. So we don't really know as much as we would have liked to know. We really don't know. So that's the most crucial part. I would come back to the quote I started with, that This is again a BBC picture of the tsunami rushing in towards the village that was, the city that was just in the afternoon, the calmness of the afternoon. And I come back to this quote that the civilizations exist only by geological consent, and it can change without notice. So my personal philosophy is that these forces, like earthquakes, tsunamis, the volcanoes, all of these are part of Earth's activities. These activities have given us the gift of our mountains, our oceans, and our river systems, and our rich soils, and all the things that we enjoy today, like the tourism spots, like Fiji volcano is one of the tourist spots of Japan. You pay extra money to get a hotel room which faces the Fiji volcano. So all these are parts of the natural processes that goes on. And they have to continue. That's the way the life can be sustained on this planet. The thought is that should we not leave space for the forces of nature to operate? Sendai earthquake turned out to be a catastrophe because the nature did not have its own space to operate. And that is where we need to think about. I might sound emotional, but I think we need to think about, should we not leave that little space for the nature to operate? Thank you so much.
You said 1,000-year cycle and is it just observational, or is there any basis for it?
For the 1,000-year cycle, it is mostly geological. And in Japan, it is historically documented. Even in India, we have actually some archival information to suggest that the sea did come into Kaveri Pattanam. So that time people don't know this. So they say that this was inundated by a sea incursion. The geographic, the archaeological survey reports that. In several other subduction zones like Chile, this is only geological data. You don't have the instrument data or any. But geologically, you preserve the sediments and their characteristics which are dated. So there seems to be this bigger cycles. It is observed in Kuril subduction, which is 500 years. In Chile, it is about 1,000 years. And in Cascadia also, it's about 700 to 1,000 years. So that is geological.
I have one more question.
Please.
You know that these cycles, have they anything to do with extraterrestrial features like the solar activity or the movement of planets, or there is no evidence at all?
The cycles come from the motion of the plate itself, because the plates are moving at a particular velocity. So they say 5 centimeters per year or 8 centimeters per year. This motion is what creates the stresses at the plate boundaries. And this motion is pretty much regular. And as this regularity results in a strain buildup, it has to release. So that's the fundamental reason. But you don't have enough cycles to observe, because we have been around and looking at all this only for a few hundred years. We don't have the data. But overprinted on this, there could be other factors that it is difficult to quantify. But the fundamental driving force is the plate motion, which take place at a specific speed.
I'd like to ask you whether you have any information with regard to any other tsunamis that have taken place in the Japanese environment in the last 30 or 40 years, because there have been other nuclear installations also around the coast. And if there have been other tsunamis, what was their intensity relative to what's been observed in March of this year?
I do not have so much of statistics on that, but most of the recent tsunamis were not so big. And they have these, the walls or breakers which will break them off. And the power plants have been there only for a short time. So we have only the historic earthquakes which would have gone that far. And in the recent, after the nuclear plants have come, I don't know how many tsunamis may have come. They are not so many. And they are just protected. I think this...
The plant Plants have been there from 1970 onwards.
1970.
Some if you even a little earlier.
Yeah.
Certainly there are 40 years of observation.
Yeah, right, yeah. But there we did not,
1920.
yeah. But there we did not have this kind of tsunamis during that small, interval. So like 78 was the largest in this area. But I confess that I don't have a proper statistics of all the locations of the power plants and what they really have there, whether there are breakers or, those details.
If the plates slip and there is a length, why does this thing occur over a epicenter like a center point and not over some length of the plate?
Actually, it is not a point. It is actually a zone. It is basically a rupture. It's a rupture. See, what we say, we are generally used to modeling any source of energy as a point source. But it is really not a point source. It is like a couple of forces which are really acting, and it is just a area that is actually getting affected. That's why you will see this moment magnitude, I put it MW. That MW means that this is the area that has ruptured. So it is not a point. And that rupture, that's what I said, it might run for 300 kilometers or it might run into 1,000 kilometers, like in Sumatra. It is not a point. But the way we represent it, it is just a projection of that point where it nucleated. That is a projection.
If we had to give nature its space to operate, and if we were to plan for 1,000-year events, we would leave the 4 kilometers of seashore unbuilt. Should we plan for a 1,000-year event or just 30-year event and then take the hit once every 1,000 years?
Tricky question. But see, I don't know. I was just wondering if the Japanese plants, the particular plant that was affected, had it been a few kilometers inland, maybe the energy to pump the water would have been more. But they have put it right on the shore. So when I say that, it's on a larger philosophical ground that I said that we need to leave that space. This is not just about the tsunami. If you go to the Himalaya, you will see how the hills are just being ripped. Today we are just concerned about the tsunami. Nobody worries about what could happen if an earthquake of magnitude 8 is to occur in the Himalaya. We have all kinds of situations. So it is just not that we need to, the question is not whether we should construct it at 500 meters or 4 kilometers. Fundamentally, we have to leave that space. That is what I feel. So depending upon the situations, we need to be more, we have to change our approach. That is what I feel. We have to understand that nature needs its space. I am sorry, I can't say more than that. I just feel that we have to study the situation like Makran coast. You have a plant right on the subduction zone. We're so dangerously close to a subduction zone. So these are the issues that...
May I ask you a question about the Indian plate? As you said, as we also have seen, the Indian plate is moving. What is the sort of movement of the Indian plate, and how seismically active is that area where the Indian plate is pushing obviously against the European plate?
Yep. Yeah.
Have we done any studies in India? Have we got substantial data on the seismic activity, especially in the northern areas of India? Because I know I was in Delhi when we did have an earthquake, and it did shake us up a bit.
Okay.
I was in Pune, it did shake us up a bit.
Yeah.
So I was wondering, have we been doing some observations and studies on the movement of the Indian plate?
Yeah.
I understand the Himalayas are also growing a little bit.
Yes, actually, we don't really look at the movement of the Indian plate per se, but we look at the seismicity of the Himalaya, and we work on what is the possibility, what are the sizes of the last earthquakes. So the Indian plate is moving about 5 centimeters. There are GPS estimates that tell you that. The controversial issue about the Indian plate and the seismicity of the Himalaya is, or not controversial exactly, the rather widely discussed issue is that we have had 4 great earthquakes since 1905. 1905 we had one in Kangra, 1934 we had one in Bihar, Nepal area, we had 1950 Assam, 1897 Shillong. So during this short interval of about 200 years, we have had 4 great earthquakes, more than magnitude 8 earthquakes. Since 1950, we have not had any earthquakes. of that size. That's one issue. So everybody believes that an earthquake could happen. Adding to this confusion is the fact that between the 1905 Kangra earthquake, and which affected places like Dehradun, and the 1934 Bihar Nepal earthquake, there is a large gap. This is what is perceived mostly as the central seismic gap. A gap is where the same force or the plate motion applies, but it has not generated an earthquake. That is a gap in seismicity, which means that the stress is building up. Some years ago, in 1980 or so, a paper came out in Nature saying that this region is now ready for a great earthquake. So that still remains, that it has not occurred. We actually look at myself and my husband, who's a geologist, we work together on these issues. So we actually look at all kind of information, like the temple, the destruction to temples, geological data. So what we have gathered is that, in fact, that's a paper that it's just coming out in Tectonophysics about the recurrence of this gap. We believe that it is about 1,000 years, that particular earthquake. So we are working on that. There are recurrence intervals estimated based purely on geological data, and now also using archival data from the temples. I'll tell you, like, even temples tell you a lot, and there are lots of large temples there. You can actually visualize the rotation on the pillars. You can use those rotation and the mass of the pillar to calculate the acceleration. So these are all being done. I mean, we can do it. So there are things that we are working on, trying to understand when, and then you have the date on the temple. So you have a benchmark, okay, this is between 10th and 12th century. So we are trying to understand that. So it is still quite a lot of, a long way to really reach, better benchmarks.
Now you are very near to history. May I ask one question relating to history? Is there any evidence of sunken continent or landmass as a result of this tectonic movement? Because there was some speculation in the beginning of the last century that while laying the cables, say, across the ocean, some of them speculated that the sunken continent evidence is available because of the undulated terrain found on the seabed.
Yeah.
Do you have any, can you throw some light on this?
See, sunken lands occur also due to the climate change. Because between 17,000 and 7,000 years, there was a glacial melt. So a lot of land got submerged. That is one aspect. But tectonic submergence is possible. In fact, if you look at the areas where I have worked, the closest I have come is Run of Kutch, where you can actually see that there used to be a sea. There it was not sinking, it was actually coming up. So there used to be a sea which got closed, and today it's a land. So there are examples. But I don't really have, we do have, like, I showed this 1 meter subsidence. Eventually, they will keep on subsiding. I don't have a much better example to tell you that this is subsided by this much.
Continents?
No, I have not learned of that.
Excuse me. Is there any relationship between greenhouse gas effect and any tsunami occurring? Is there any relationship, or are there no relationship between these two?
I have always learned the tsunami generation as a process that takes place at the plate boundary. I really can't think about, I can't put a scientific basis on reading a good argument, to say that, because to me it's largely the dislocation on the plate boundary, the rupture on the oceanic plate.
Thank you, Rajendran. It's very nice that you have been able to enlighten us, and thank you very much. We have a small break now, and we'll have a tea break, and we reassemble in about 15 to 20 minutes.
Thank you very much.